Hi everybody, we are Team CEBA. I am Reed Gilbert.
I'm Robert Money.
I'm Will O'Brien.
And this is our bubble machine.
We're going to talk to you about the design cycle.
The basic idea of our design is we needed a way to get the bubble wands to move through solution so that they could cut a solution just like a regular bubble wand. And then we needed a fan to blow the bubble out of the bubble wand. So basically just two easy steps there. We just had to figure out how to power each one. So the hardest part was figuring out how we were going to create a motor that was less than 6 volts that would be able to move it slow enough for the bubbles to still be blown out of the bubble wands. So what we ended up doing was using a Lego motor, one of the advanced Lego kit motors, which unfortunately run at 9 volts, so we had to modify the inside of the controller to run off of, it's actually running off of 3 volts, 2 AA batteries, each 1.5 volts. So it does comply with the voltage requirements for the project.
So the way we created this is we had to create a box that would fit our Tupperware, where we drilled made a hole, cut a hole, and we put the Tupperware container into it so we'd have space for the whole contraption. We built almost like a little diving board for the machine to sit up on, and you can see that we have these little tin cans here, which whenever the bubble solution is coming off of this, it drips down, and so we don't have any waste. Very kind of clean and more efficient, and so yeah, that's the overall gist of what we made.
And luckily we did actually find a fan that complied with the voltage. This is also 3 volts, just 2 AA batteries, that luckily was powerful enough to blow the bubbles out of the bubble wands pretty well. We just had to put it pretty close to the wands. It's just kind of sitting on the back of the motor. So this is the Lego controller. Pretty basic, just the cable connects to it that controls the motor. But there's slot for 6 AA batteries, which unfortunately would be 9 volts. So in order to comply with the requirements of 6 volts, I put in wires that complete the circuit, and I soldered them on, and they were running off of just 2 batteries, so 3 volts. And they're soldered on, so it's pretty solid. We didn't have to worry about the wires breaking, unlike what we'd have to worry about if we just taped them in.
Engineering at its finest. So here we see the machine is running. You can see how the bubble solution would be filled in the container right here. The wands would dip, and with the fan turned on, the bubbles would be blown and come off and obviously make bubbles. One of the requirements is the bubbles have to detach, and so we had to put the fan close enough to where they would detach, but not too close to where they would burst on impact because there was too much force, but not too far away that not enough force would be applied to the bubble solution, and because of this optimal range that we found, more bubbles were blown.
Okay, so we had a few challenges making this. One of the first challenges we faced was, first of all, figuring out what kind of motor we're going to use to spin the bubble wands. The major issue was we needed something that would spin slow enough for the bubble wands to go in front of the fan, slow enough that enough air could get into the bubble. First, we were going to use a Radio Shack DC motor, but they were spun entirely too fast and didn't really know how to slow it down. We also thought about using a drill, like a cordless drill. But those run off of generally 12 volts and didn't comply with the requirements. So we ended up choosing we had a Lego motor kit, and that spun pretty slow, and you're able to gear it down given the gears that are included with the kit. And the only challenge with using the Lego motor was the 9 volt controller. So like we showed before, we just put in the wire to complete the circuit, and we put it down to 3 volts, which also made the thing spin slow enough that it was able to blow the bubbles out in a pretty decent manner.
At the engineering fair, we tied for 3rd in the bubble blowing contests.
They pretty much judge off of being original, not using too many commercial parts and pieces. You can use bubble wands. That's the only commercial thing that you can use that's related to bubbles. And they also kind of rate you on your creativeness and kind of like putting in engineering skills that you learn in your classes, and kind of promoting you to being a successful engineer.
One thing that maybe would have done differently if we were to do this again is that a lot of the other teams used a fan that plugged into the wall. I was under the impression that we were not allowed to use things over 6 volts no matter what, but apparently it didn't apply if you used a thing that's actually plugged in. So that would have worked a lot better if we'd use a larger, room fan, or a lot of teams use hair dryers, which worked really well. So if we had known that, we would have used that for sure, and that would have probably made the bubbles bigger and fly farther away from the machine, which would have increased our score.
The advice that we would give is, first, I would use a plug-in fan, because the groups that came in the top 3, the 2 tied for first, the people who came in second, and who we tied for third, all used a plug-in fan or plug-in hair dryer, and that created bigger bubbles and spread the bubbles out even further. Whereas we used this tiny fan and didn't get as good as a range with bubbles.
Yeah, but also another tip that I would like to kind of throw in is that teamwork is key. We all put in a lot of work in this, and we all brought in a lot of aspects that helped out. I figured out how to create the base and kind of add these little tins to kind of improve. Robbie did a lot of work with kind of getting the spin to be the right speed and getting everything to be in the right place. And Will over here really got the motor and all the gear ratios doing the right things, what they need to do to be sufficient for the 6-volt batteries and stuff like that. So we all definitely, without each other, wouldn't have been able to make this project. No one person can do this.
Bill really helped on the research. He Googled on more efficient ways to make a better bubble solution. He saw the way that we could make that 9-volt battery a 6-volt battery, and Will converted it by hand.
Almost the encyclopedia of our project.